We have introduced a priori-based sequential pattern mining algorithm GSP. We have introduced vertical format-based sequential pattern mining SPADE. Now we come down to see pattern growth-based algorithm called PrefixSpan. PrefixSpan is a growth-based mining algorithm. Okay. To examine the sequential pattern in more detail, we need to introduce the concept of prefix and a suffix. The prefix means anything in the front, if it's frequent, you want to capture them as a frequent prefix, like A, B. Then their projection becomes a suffix. Remember, if you get AA, what you see is you got a position holder for the next one is B. So that's why we use underscore as a position holder. Okay. The similar thing, you get AB, the position holder will shift to C. So that means given a sequence, you will find a set of prefixes and a set of suffixes, or you can say prefix-based projection. Okay. Then for this projection, what we will find is first find length 1 sequential pattern. If they are frequent, we call them a length 1 sequential pattern. Then we can do divide and conquer. That means we divide the search space to mine each projected database. We have A projected database, B projected database, C projected database, up to F projected database. This mining methodology called PrefixSpan or prefix projected sequential pattern mining. So let's examine a little detail. For this sequence database, if we find length 1 sequential pattern like this, then we can actually get length 2 sequential pattern by first doing projected database, then find length 2 sequential pattern. That means if they are frequent in this projected database, they will form length 2 sequential pattern. And then we can do length 2 sequential pattern based projection, find AA project database, AF project database. Okay. Then we can keep this one ongoing. Okay. The major strength or advantage is there's no candidate subsequence to be generated, and the projected database keeps shrinking. So let's look at some implementation tricks. So if you do the projection, like you're really taking the sequence to do projection on A, projection on AB, you will get largely redundant subsequence, or you say postfix, but they are largely redundant with the original string. However, we do not need to do the real physical projection. What we need is we call pseudo projection. That means you just say, what is A's projected database? It's the same sequence, but the position is number 2. What is AB's projected database? Is the same sequence on S, but the position is number 4. So if you register the next position to be scanned, you essentially register the projected sequence or suffix. So if the database can be held in the main memory, this pseudo projection is very effective because there is no physical copying or suffix. You only need pointer to the sequence. You just get offset, you get suffix. But if it does not fit in the memory, you use pointer, you may involve lots of disk accesses. So you may really want to do physical projection because once you project it, quickly this set can be fit in the main memory. That means we can integrate physical and pseudo projection. Anytime when the data fits in the main memory, you can use pseudo projection.